Another property of liquid that is worth mentioning here is the phenomenon called capillarity. Capillarity again is related to the intermolecular forces of the liquid and the forces that exist between the liquid and the forces of the container. This will be a good introduction when we start talking about solutions, which is pretty much the interaction between two types of compounds. So what is capillarity? Something that you may be very familiar with. When there's a straw on a liquid, you may see the raising level of that liquid and also a concave kind of meniscus. Why does that happen? Why is it that when you put a straw in water, for example, the level of liquid goes up? That's because there is a competition between the cohesive forces between molecules themselves, right? How well molecules interact with each other and how well molecules interact with the plastic or whatever the tube material is made out of. In this case, when the adhesive interactions are positive, are stronger than the cohesive, the liquid will rise. In other words, the water in here would rather be interacting with the walls of the container than with the neighboring waters. When you see that, that's a phenomenon called capillarity, and you will see the level of water increasing. Something that you may be also very familiar is a towel drying off. Why is it that some materials can dry? Is because water will interact with material better than with water itself. So you will see a meniscus being concave. The meniscus is this level and it has the concave shape. On the other hand, and that depends on the liquid being submerged in the straw, you may see that in this case, for example, mercury has a stronger cohesive forces, and therefore the adhesive forces do not compensate those cohesive forces. In other words, the mercury would rather be interacting with other atoms of mercury than with the walls of in this case glass. What happens then is that there is a depression of the level of the liquid, and you will see a convex meniscus. Okay, so just for the fun of it, let's see if we understood what we just said. In this case, saying, well, when the adhesive forces between a liquid and the walls of a capillary tube are greater than the cohesive forces within liquid, what happens? Well, if the adhesive forces are greater, what you will see, like imagine that this is the straw, you will see the water, the level of, I'm saying water, but it could be any liquid, as long as the adhesive forces are greater, it will increase and you will have a concave meniscus. So it offers here 5 possibilities, and all of them are, the variables are either the liquid will rise or it will drop. Okay, we said that if the adhesive forces are greater, the liquid will rise, and the meniscus will be either convex or concave. We'll say that it'll be concave, so B is the right option. Okay. Again, let's go over why is it that sometimes you don't see the liquid rising. So the meniscus of mercury in a glass capillary tube is convex because of, why is that? Well, is because if you go through the options, the weaker attraction of mercury atoms to the glass than to each other. In other words, mercury would rather be interacting with other mercury atoms than with the glass. So if you have mercury, they will try to minimize the contact with the glass, therefore you will see this kind of depression level and convex shape. Okay, there is another kind of property of liquids that we will go very fast, that is called viscosity. So we have mentioned capillarity, we have also mentioned surface tension. We will not talk too much about viscosity other than just solving these two multiple choice questions. What is viscosity? Well, viscosity is the resistance of a liquid to flow. You can imagine, right? So if some liquids are more viscous, What does that depend? Well, viscosity depends. So you'll have a high viscosity when you have high intermolecular forces, when you have lower temperatures, when you have non-spherical shape of molecules, and when you have a high mass or high molecular weight of the molecule that makes up the liquid. So just identifying these, which of the following factors contribute to a low viscosity? We're interested in a low, so we said that at low temperatures there's high viscosity, so that cannot be, okay. We said that high intermolecular forces, also of course you'll have a high boiling point, so it cannot be hydrogen bond and high boiling point. Again, we're interested in low viscosity. We said high molecular weight will give you high viscosity, so that's not correct. The right answer is the spherical molecular shape. You don't need to remember all these factors, but it's important for you to understand that it makes sense at atomic level that viscosity may be affected by all these variables.